So your first midterm will be November 4, which is Wednesday. Hey, and just to give you an idea, this will be open book, but no laptop, no cell phone.
And it's okay, professor, to print our assignments?
Yeah, you can print anything you feel like it, bring anything you feel like it. Paper is okay, but no electronic media.
Okay.
So especially no cell phone. In the past, students have taken pictures of their work and shared with everybody. So this time I'll be very strict about it. Yeah. Okay, what did you guys cover last week? Databases, some more databases? Okay. Let me, just in case there was any confusion, I'll quickly review the databases and then cover the interfaces and a few other things, right? Okay, so let me quickly go over the concepts of databases, okay? See, once we communicate with the database, here, let's say this is a database server, okay? And this is our application. So typically what happens is database server is either on a different computer, but even if it's on the same computer, it's a separate application, okay? So anytime we communicate between two computers or two separate applications, we communicate via what are called sockets. Okay, so that means our database server is listening on a different port, right? Okay, so when we write our code, database code, our typical code goes like this. Specify connection string to the database. Number 2, create a connection object. Number 3, open the connection. Number 4, compose SQL. Number 5, issue SQL. Number 6, process results. And number 7, close the connection. So no matter what database you are dealing with, once you're writing the code, typically these are the steps we go through, okay? What's the purpose of the connection string? The purpose of the connection string is to identify database server and some authentication information, meaning how will we log into the database server and which database. Okay, so to give you an idea, let's say your database server is on a different machine, okay, and the machine has an IP address, let's say 192.168.2.105. Let's pretend, okay? So once you're specifying a connection string, this is just a string, so it will look something like this, string, and you can call it anything you feel like it. I typically call it constr, short for connection string, right? Okay, so there are 3 parts to the connection string. Which database server? So for example, I'll say over here server equal to 192.168.2.105. Okay. Now, that's the IP address of the machine, right? Okay, on one machine we can have many database servers. There could be Oracle running over here, there could be SQL Server. So typically further, you identify name of database server. And I'll show you as I go to the computer how we find that out. Okay, so that's the first part of the connection string. The second part of the connection string is some authentication information, meaning how our code, so see this is where our code is, how our code will identify itself to the database server, so the database server allows us to issue SQL. Okay, so you can create some user ID, for example, hello, password, whatever. Okay, let's say top secret. Okay, all of this has to be typed on the same line. Okay, then semicolon. So semicolon basically separates the different parts. So this is the user, this is the password, right? The third part of our connection string is which database. So if you created some database, let's say database equal to, let's say, products DB. Okay, so this is what we call the connection string, right? So once again, it has three main parts. Which database server, which could be the domain name of the machine or IP address of the machine, backslash or forward slash, doesn't matter, name of the database server, okay? And again, once I go to the computer, I'll show you how exactly you know which database server, right? So then there's an authentication information. So this is our authentication information to identify ourselves to the database server. And this is the name of the database we are interested in communicating with, right? So that's the connection string. Okay, now let's go to the second part. Okay, the second part, in the second step, we create a connection object so that we can open a connection and issue SQL to the database server, okay? Now, how we create the connection depends on which database server we are trying to communicate with, okay? So we have different classes available to us. For example, if you are trying to connect to a SQL server, the class is called SQL connection. Okay, so you will say something like this, con equal to new SQL connection. Okay, and in the constructor, you will pass the connection string that you had specified earlier, right? If you're trying to communicate with Oracle, then this SQL will become Oracle. This SQL will become Oracle connection. If you're trying to communicate with DB2, it will become DB2. DB2. Right? So depending upon the name of the the type of the database server, the class name changes. Okay? So anyway, that's called creating the connection object, right? Then the rest of the code, from opening the connection to composing the SQL, typically we write it in a try, catch, and finally block. Okay, in the finally, we always close the connection. Remember, the finally block is always executed regardless there's an error or not. So this will make sure that we don't leave the connection hanging, because if too many clients connect to the database server and the connections are open for a long time, then over a period of time the database server will run out of connections and your whole application will start to either not work or work very, very slowly. Okay? Okay, so so this part over here, so steps, all of these steps, compose SQL, issue SQL, process records, all of these are done. So steps 3 through 6 are done over here. Okay, the closing of the connection is done in the finally block. Okay. So that's the typical code. Okay, so now let's take a look at how do we open the connection. That's very, very easy. There's simple one-line statement, con dot open. Okay. Compose SQL and issue SQL depends upon what are we trying to do. Okay, so let me go over here. So composing and issuing SQL. Okay, so typically there are 4 kinds of needs that we have with the database. Okay, we want to get a single answer from the database. The single answer situation could be you are trying to log in. All you care is, does this user exist in the database? Or you wanted to find the price of a product. Okay, so see, in that case, all you care is what is the price given some product ID. So those are the type of situations which I call where we want just one answer from the database, right? A second scenario is where we want more than one answer, so more than one row and column. So more than one row column from the database, right? Third situation is we either wanted to insert some data or update some data in the database or delete data in the database. All 3 come in the same category, okay? And lastly, what if we wanted to trigger a stored procedure in the database server, right? So those are the 4 types of needs that we have. So when we compose the SQL, issue the SQL, process the results, it will depend on what are we trying to do. So the code will look different if we are trying to do this. It will look different if we are trying to do this. It will look different whether we are inserting, updating, deleting, or whether we are calling a stored procedure, right? So now let me show you how steps 4, 5, and 6 vary based on our 4 types of situations, okay? So first let me show you in plain English. If we wanted a single answer from the database, we typically create a command object. Okay, then we issue, or we call execute scalar method on it. And this returns an object. So returns an object, which is the base class. And then by using object.toString or object.whatever data type you have, typecasting it to that particular object, you can get your answer, whatever single answer you were trying to obtain, right? Okay, now once you create the command object, my suggestion is always tie it to 2 things. Always tie it to a SQL and the connection object that we had created over here. Okay. So once again, the name of the command object class will be either SQL command if you are trying to communicate with SQL Server, or it will be Oracle command if you are trying to communicate with Oracle, and so on. DB2 command if you're trying to communicate with DB2, right? Okay, now if you want more than one row, one column from the database, right? Then the code changes a little bit, okay? Instead of creating a command object, okay, so for this situation, okay, you will create a data adapter object. Okay, and then you will create also a data table. And then you will call the fill method using the data adapter object. And I'll show you the code in a second. Okay. So before I show you the real code, the question is, why do we have a different object over here? Why do we have a command object over here? And why do we have a data adapter object over here? So why do we have two different things over here? Okay. Why not have the same thing? Okay. The reason is like this. Okay. Once we connect to the database server, okay, see on the way back, we need to bring back some result, right? So we want to send the SQL to the database server, and we want to bring back some results, okay? So think of a command object like a motorcycle. Okay, it's a very lightweight object, meaning it can carry only one thing back from the database server. Okay, so that's why once we have the single answer type of situation, okay, meaning we want to bring back just one thing back from the database server, okay? So we send a motorcycle, okay? So motorcycle, whatever the picture is, we tell the motorcycle what SQL to carry to the database server, right? We also tell it the connection, because remember, connection object has all the information, meaning which machine to go to, how to identify itself, and what database to issue the SQL to, right? So that's why anytime you create the command object, always give it two pieces of information. The SQL to carry to the database server, and the connection so that it knows once it delivers the database, delivers the SQL to the database server, it can identify itself properly, right? Okay, so on the way back, even if the SQL says give me many rows, many columns, okay, suppose the SQL we sent over here was select star from products, okay. Because the command object is very lightweight, it doesn't have the storage capability to bring back too many things. It will throw away everything, pick the very first row, first column of whatever reply the database server gave us. Just pick the first row, first column, and only bring that back. Okay, so that's how the single answer technique works, right? Now coming back to what if we wanted more than one row, one column from the database server, right? So think of the data adapter like a truck, okay? So because we want to bring a lot of things back, we will send a truck to the database server. So data adapter is like a big truck, okay? On the way back, okay, on the way back, it doesn't matter how many rows, columns we have, it will carry them all and bring us back. And then this data table that we created is like a data structure which is capable of storing many rows, many columns. So what the truck does is, which is the data adapter, just dumps it in our data table so that we can get all the rows, all the columns that we wanted, right? So that was our second technique. If we wanted to insert, update, or delete, so now the question is, should we send a motorcycle to the database server or should we send a truck?
Motorcycle.
Okay, and the way you can answer that is, what will we be bringing back? If we issue an insert statement, what does the database server give us back? Number of rows modified, which is just one thing. Same way, if we update, it will tell us how many rows were updated. If we delete, database server will tell us how many rows were removed, right? So it's just one small thing that it returns back. So sending a truck will be an overkill in this case. So that's why for this technique, insert, update, delete, we create a command object. And again, depending upon what database it is, if it is SQL Server, the class will be called SQL command. If it's Oracle, it will be called Oracle command, right? Okay, now we already created a command object for the single answer scenario, right? So execute scalar was the method to bring back one thing. So rather than calling execute scalar, the difference is over here we call execute non-query. Okay. So that's our, again, once you create the command object, you will tie it to SQL, you will tie it to the connection object, right? Okay, lastly, stored procedures are nothing new. They are just a variation depending upon what the stored procedure is doing. If the stored procedure is returning one single thing, what will we do? We'll create the command object, right? So the question is, what will be the SQL in that case?
Stored procedure.
The name of the stored procedure will be just the SQL. If the stored procedure is returning many rows, many columns, what will we do? Create the data adapter. When we create the data adapter also, we also tie it to a SQL and the connection. So what will be the SQL in case of a stored procedure?
Name.
Just the name of the stored procedure, right? The only small difference is once we create stored procedures, sometimes, see, stored procedure is like a method. Sometimes we have to pass parameters to it. So there's one extra class involved called SQL parameter or Oracle parameter, depending upon which database server you are creating. And so first you have to create the parameters. You have to put them inside the command object. And if the stored procedure is returning many rows, many columns, you will create a data adapter and you will tie the command object to the data adapter because only the command object has the capability to store parameters. Okay? Anyway, let me go to the computer, create a small example, and show you how easy it is to communicate with databases. Okay, by the way, the Visual Studio 2015, our graduate assistant Somaya already has a copy of it. So if you need to obtain SQL Server 2015, please contact her. And we have the university copy, so you can get the latest version. Okay, for dealing with databases, you can download SQL Server 2014 Express Edition, which is free. Okay, that's the latest and the greatest. So, anyway, once you download SQL Server, Alright, so for some reason I'm not able to connect over here. Alright, so okay, so anyway, once you've downloaded the SQL Server 2014 Express Edition, one of the things you will get with it is called SQL Server 2014 Management Studio. Okay, once you launch that, Okay, so this is a very easy utility to create databases, to manage databases. Okay. Okay, so once you launch it, it will ask you to connect, and you can leave the authentication as Windows authentication. Okay, so over here, this is the name of the database server. So once I installed it, I gave it a name, Nano SQL EXP14. Okay. If you don't give it any name, it will pick a default name by itself. Okay, so anyway, just hit connect and it will connect to the database server. Okay, so once you are in the database server, now we can create databases, do anything we feel like it. So how do we create a new database? Very easy, right click on the database folder, choose new database. Once it shows up, okay, now you can give it any name. For example, let me call it products DB. Okay, products database. Whatever the defaults are, don't worry about it. Just simply click OK. So this will end up creating a blank database for you. Okay, once the database is created, you'll see there's a folder now, products DB, right? Of course, there are no tables over here, just the system tables. If we wanted to add a new table to it, you can simply go right click on tables and just click on this table. Sometimes in an older version it will say new table. So we'll take you to the table designer. Now you can specify, so for example I can say product ID. And data type, because it will be a number, for example, let me pick the data type to be, my computer is pretty slow. Just going to do something. So anyway, data type, I have a choice of int or big int. So depending upon how many products you see, anyway, let me pick this to be int. You should always have any table you create, you should have one or more primary keys in the table. If primary key is like a unique column, meaning a particular row will be uniquely identified by that. If you can't think of a single unique thing, then you can pick multiple columns or create an auto-generated column as the primary key, right? How do we set the primary key? Simply right-click over here and set the primary key. So that means no two products will have the same product ID, okay? Anyway, let me just pick, let's say, product name. Okay, suppose this is, each product name will be up to 100 characters maximum. So there's a data type called varchar, and you can pick any number inside it. So variable characters, maximum 100 characters, right? Uncheck allow nulls. Anyway, so let's say price will be one of the, so price, there's a data type called money as an example in SQL Server. Okay. What else should we say? Let's say units in stock. Okay, so for example, that could be an int. Okay, and you can add more. For example, you can say category ID. Okay, which can be an int, and we can tie it to another table. Okay, so anyway, once you are done creating whatever columns you need in your database, you can exit out. So once I exit out, it will ask me for the name of this table. Okay, save changes, say yes. Okay, the table name, I'll give it products. It's a good practice to give table names a plural because sometimes there are auto-generated tools which will create a corresponding class for your database table. So if it is a plural, then it will remove the S and it will create a class called product representing each row, which makes sense. So if you already made it singular, meaning product, then it becomes a little confusing. Is it representing one row or is it representing the whole table? So anyway, now that our table is ready, okay, now we can go and if I right click over here and refresh it, you'll see the products table appears, right? Now we can enter some data in it. So if I right click on it, say edit top 200 rows. Let me put some data in it. For example, product ID, let me say 100. Product name, let's say laptop. Price, let's say $5.95. Units in stock, let's say 25. Category ID, suppose I say 10. Okay, so pretend 10 is for electronics. Anyway, next one I can go 101. For example, I can say calculator. Okay, then I can say price 35.95. Okay, units in stock, let's say 20. Category ID 10, right? Let's say we have product ID 102. Suppose it's a tennis racket. Okay, suppose the price is 150. Okay, units in stock, let's say 30. Okay, let's say the category ID is 20. So 20 means sports, let's pretend. Okay, so 10 is electronics, 20 is sports, right? So anyway, so similarly you can add as many things as you feel like it. Once you're done initializing the table, you can X out the table designer and it will save all the data. And if you're not sure, right click on the table again, edit top 200 rows, and if you see your data, so now our database is ready, at least it has one table in it, right? What was the name of the database I created? Products DB. Okay, what was the name of the table? Products. Okay. Now, once we create a connection string, we will need to know the name of the database server, right? So see at the top left, this is the name of the database server, but it looks kind of complicated. So the exact name is, if I right click on it and go to properties, okay, do you see like name over here? So this is the name of my database server. Each one of you, as you install the SQL server, will have a different server name. So don't go by what I will be using. Just right click on your database server properties and right click and copy. So now that I have copied the name of the database server, I'll just cancel, minimize the SQL Server Management Studio. Now let me show you how easy it is to write the database code. So suppose I launch Visual Studio 2015. Okay, I'll create a very tiny application and okay, did Sumaya give you a database assignment or no? You already have a database assignment? Okay.
Professor, she said she will upload the details on
Of the assignment or of the
of the
lecture?
assignment.
Okay, so I'll check with her and we'll put it. Okay, so once the Visual Studio is ready, right, let me create a new project. Okay, so once it comes to the new project, I'll pick Visual C# on the left side, Windows Forms application, right? And let me browse to, we had created a folder for our CS440 class on the C drive, so let me put it over there, CS440 fall 2015, right? Select folder, and let's call it DB test. So this is a small DB test I'm doing, right? Okay, so Windows Forms application, it's Visual C# DB test, right? So once it creates the infrastructure, okay, so let me make the form a little bit bigger. Okay, I'll go put a button over here. Okay, so anyway, I'll go put a button. So let me say over here, BTN get products. Okay, so we're give it a text property of get products. Okay, so now to display many rows, many columns in C# or .NET, we have a very easy control called Data Grid View. So if I go to the data section, okay, you'll see there's something called the Data Grid View. So anytime you have to display many rows, many columns, this is a very easy one to use. So I'll just double click on it, put one Data Grid View on the form. So it will automatically expand to as many rows, as many columns as we need from the database. So anyway, once we have the Data Grid View, right? Let me just call it DG1. Okay, so that's the name I gave, right? Okay, so now if I double click on Get Products, I'll write the code for the, actually let me see if I can increase the font a little bit. So tools, options.
Can change it from here, Professor.
From where?
On the main screen,
On the main screen?
down there on the corner, 100%, the other corner. Yes, here.
How?
Change the number.
Oh, just change the number, I see. Okay, yeah, that's a good tip. Okay, so anyway, so now let me write the code for it. So just like we discussed, we'll start with the constr equal to, okay, server equal to. Okay, so now I'll paste the name of the database server that, remember, through the properties I had copied. Okay, so whatever that name is, semicolon. Okay, since I'm communicating with the database server right on the same machine, not a different machine, in that case I can use integrated security for authentication. So once I say integrated security equal to true, all that means is once we go to the database server, the same login that I logged into my machine will be used to authenticate against the database server. So that's an easy technique if the database server is on the same machine where you are writing your code. But if it's on a different machine, you have to create a user ID and password, and later on I can show you how to do that. Okay? And lastly, what was the name of the database? Products DB, correct?
Yes.
Okay, so this is what 3 parts to our connection string. Okay. Now in C#, just like Java, backslash is a problem character because \n means new line. So if you're writing C# code, anytime there's a backslash involved, you should put 2 backslashes. So that's why it's giving me an error. So I replaced the name of the database server with 2 backslashes, right? Okay, so now let's go write the rest of the code. As I mentioned, the next thing we will do is SQL connection. As I type SQL connection, you'll see it's not being recognized because it's in a different namespace. So if I right click, and where's the result? For some reason,
Quick actions.
is it in quick action?
Yes.
They changed it. Using system data. Okay, because in SQL Server, Visual Studio 2000. What happened?
Yeah.
Oh, it took a while. Okay, so it basically added this line over here. System.data. Okay, so anyway, SQL connection con equal to new SQL connection, and we will put the connection string in the constructor, right? Rest of the code will go in a try, catch, and finally block. And as we discussed, finally is always executed regardless there's an error or not. And this is where we close the connection. So this way it will be guaranteed the connection will be closed, right? If there's an error, we can just display it in a message box. Okay, so now as we discussed, first thing we do is open the connection, correct? Okay, we create the SQL, so string SQL, let's say select star from products. By the way, the SQL language itself is case insensitive, so it doesn't matter whether I type lowercase s or capital S or products P lowercase or P uppercase, okay? It's case insensitive, so it's easy that from that point of view. Okay, now I need to bring all the products and display them. So what should I use? Should I use a command object or the heavy duty truck, which is the data adapter? Data adapter. Because this is SQL Server, so I will use SQL data adapter. Okay, DA equal to new SQL data adapter. And anytime you create the command object or the data adapter, always tie it to 2 things. Okay, one is the SQL, and the other is the connection. And again, think of it this way: you are telling it to carry this SQL to the database server, but where is the database server? This connection will tell it where to go, right? Okay, now on the way back, it will bring back many rows, many columns, which we need to store somewhere in our own data structure. So the data structure, which can store many rows, many columns, is called the data table. So let's create a blank data table. And as soon as we do da.fill dt, this will now, data adapter will go to the database server, issue the SQL, bring all the rows and columns and dump them into our own data table, right? Now, if we wanted to, we can close the connection. And the reason is because we have all the rows and columns in our data table. Okay? It's always a good practice to keep the connection to the database as short as possible. so that many clients can connect to the database server and the database server does not slow down. Okay? Now, what will happen if we close the connection and the finally block further closes the connection again? Okay, it's not harmful to close an already closed connection, it will simply ignore it. Okay? Anyway, once we close the connection, now we will try to display the results. Okay, so .NET has a concept of what we call data binding. So anytime we have to display something in a user interface, this data binding makes our life extremely easy. It's basically a two-step process. Okay, and what we do is, one, assign a data source to the GUI element. And then, second step, called refresh. Okay, so 2 lines of code will let you display any complicated data that you brought. So in our case, where are we going to display this? We are going to display this in the data grid view. Remember, I had given it a name of DG1, right? So I will do dg1.dataSource equal to DT, because all of our data has been brought in this data table, right? And second step, dg1.refresh will simply display the data, right? And we are done. So this is how easy the database code is. So if I go debug, start without debugging. Okay, once the form comes in, I click over here and all the records are coming from the database and being displayed, right? Okay, so now let's talk about, very similarly, if I wanted just one record, one item, let's say the price of a product, instead of a data adapter, what will I create?
CMD.
The SQL command object, right? Instead of calling da.fill, I'll call cmd.executeScalar, right? So hopefully Sumaya has gone over the handout, so now at least you have a better idea. Now let's talk about organizing our code so that if you're creating a large application, in many places you are dealing with the database, right?
Professor, if we have single object, then how we can display that in data grid view?
You won't display it in data grid view, you'll display it in a label. Yeah. Okay, so now the question is, let's say in our application there are 80 different places where we are going to the database, bringing some data, doing something with it, right? So 80 different places you'll have this type of code. Okay? It may change slightly, the SQL may change, or the adapter may change to a command object, right? But that's not a clean way to create the application. See, we always try to create reusable code so that the amount of total code we are writing is as less as possible, right? Okay, so the best strategy is create one class for all your major needs. Remember we talked about 4 categories. Get a single answer from the database, get many rows, many columns, insert, update, delete, and stored procedures, okay? So now let me go create another class. So if I right click on name of the project, if I say add new item, okay, pick a class, and suppose I call this class data access. Okay, data access. Okay, now one option is I start writing 3 methods over here. So for example, I can write public object get single answer string SQL. So meaning it will take the SQL as an input. So if somebody wanted to know the price of a product, the SQL might be select star from products where product ID equal to whatever 100, right? And this will go make the connection to the database, create the command object, issue, execute scalar, and return whatever object we get from the database. So this way, anytime we need one item from the database, we can just call this method. So our life will be a lot easier, right? Okay, now let me introduce one more concept in modern software development. Okay, so let me go. Okay, so in modern software development, okay, we use design patterns. So we use quite a bit, quite a few times what are called design patterns, okay? What are design patterns? So design patterns are basically